Hello, Mr. Mailer here, online math teacher. Welcome to my channel. Today we're going to be continuing my video series on trigonometry, and we're going to be doing a follow-up to my first video on simplifying trig identities and doing a few more examples now. So if you didn't watch my first video, go take a look at that. Again, I just want to walk us through a few more examples of simplifying trig identities using my three main principles of looking to apply reciprocal quotient and Pythagorean identities, utilizing your algebra skills such as combining fractions, factoring, or multiplying by one in a fancy way, and when in doubt, writing everything in terms of sine and cosine to help you simplify identities. So if you're going to find this video helpful, hit the like button, consider subscribing, and let's go. So in the last video, I walked us through this first example here, so go check that on the other video if you want. I'm going to take us through another example now. So this example is 1 plus tangent of theta divided by 1 plus cotangent of theta. Now, in the last video, the first step, I was able to recognize that I had algebra that I could do. So I could multiply out these factors. Here, there's not really any algebra you can do in the first step. And since there's no squares anywhere, there's no Pythagorean identities I can apply either. So this is a good instance of a when in doubt, write everything in terms of sine and cosine. So the way we can do that is by using our quotient identities to rewrite tangent and cotangent in terms of sine and cosine. So here you can see I used my quotient identities and did that. From this step here, you have a couple options. You could say, well, what happens if I combine the fractions in the numerator and combine the fractions in the denominator? So, but what I mean by that is combine the one in our fraction in each case. And there's nothing wrong with that. Your other idea could be, I want to get rid of fractions and fractions right off the bat here and try multiplying the numerator and denominator by something that'll clear both of the fractions in them. So let's take a look. There's nothing wrong with exploring different directions to see what happens. So here are our two different approaches. We could do option one where we've combined our fractions, or option two where we clear the denominators of the fractions inside the fractions. Let's take a look to see what happens if we go fully down this road for option one for a bit. So from here, you might say, well, I still don't see any Pythagorean identities, but there's still these fractions inside my fractions. So let's get rid of those by multiplying the numerator and denominator by something that will clear them. So what will clear them is really just multiplying by one in a fancy way. In this case, multiplying both numerator and denominator by cosine theta times sine of theta. So here's what I end up with. If my cosine will cancel out the cosine of the numerator, my sine will cancel out the sine of the denominator, and I'll still be left with the sine and cosine up top. But moreover, what were the numerators before are now factors in the numerator and denominator. Cosine theta plus sine of theta, since addition is commutative, is the same thing as sine of theta plus cosine theta. So those will cancel out now, leaving me with my sine of theta divided by cosine of theta. And here, if you know your quotient identities, you'll recognize that this is the same thing as tangent of theta. And that's about as simple as this is going to get. I can't do much better than getting it to look just like a plain old trig function like tangent of theta. So this is what we got if we followed that road for option one. If we had went down the road for option two, which started with us getting rid of those common denominators. So what we really did was multiply the numerator and denominator by sine of theta times cosine of theta each. So multiply by one in a fancy way. That got us to this location. So we've canceled out some denominators and ended up with some extra sines and cosines. Here you might say, well, I could try applying some Pythagorean identities, and that would expand out the numerator and denominator more, but there's maybe a better way to go than that. So you could try that way and see what happens, but at some point you want to get it to look less complicated instead of more by expanding. So to not expand it, what I notice is there's sines in both those terms in the numerator, and cosines in both the terms in the denominator. So I'm going to see what happens when I factor those common things out. So when I've done that here, I now have a sine theta and a cosine theta hanging out by themselves. But again, I have this cosine theta plus sine of theta factor in the numerator and a sine of theta plus cosine theta in the denominator. And since algebra is commutative, or addition is commutative, sorry, algebra isn't always, I can just cancel. And that leaves me again with a sine of theta divided by cosine of theta, which I can then apply my quotient identities to tell me this is tangent of theta. So going through this second option still allowed us to get to the same conclusion. And that's one of the neat things about proving trig identities or simplifying them. There's more than one way to go about them to get you to the correct answer. So don't always feel like you need to find the shortest path. Find the path that makes most sense to you. Do what feels right to you, as long as it's a valid operation. So, I hope you found this video helpful. If you did, hit the like button and have an awesome day.